Chapter 8, Lesson 6 is about geometric probability. Go ahead and pause here and put these notes down. Okay, so we have 3 steps here in these problems. First, we need to find the area of the sector, then find the area of the circle, and finally, the percentage of the circle that the sector is. So according to my formulas for the area of the sector, I'm going to start with the degrees over 360. So looking here, I have this angle of 100 degrees over the whole circle, which is 360. And then I'm going to multiply it by my formula for a circle, which is pi radius squared. I also am going to type in just the pi radius squared because it asked me also to find the area of the circle. So for the first part, 100 out of 360, pi 6 squared, 31.4 centimeters squared. And then for the other part, I'm just doing pi times 6 squared, which is 113.1. Now it asked me for the percentage of the circle that the sector is. So if I want to do a percentage, I need to divide my sector out of my circle. 31.4 divided by 113.1 gives me 0.28. And I'm going to change that into a percentage by moving it 2 places to the right, the decimal place, and so it is 28%. So 28% of this circle is covered by this sector. Number 2, I'm going to write down my formulas. So I have 83 degrees out of 360, pi 13 squared, and my circle is just pi 13 squared. This is 530.9, and the other one is 122.4. Then for my percentage, I'm going to divide the 122.4 divided by 530.9. Gives me 0.23, which is 23%. On this one, where we're selecting random points, and it's going to give us a probability. For this probability here, we're going to find that by doing the number we want over the total there is. So for example, if you walked into your classroom and you wanted to know what is the probability I pick a random student who is wearing a black shirt. So what you want is a person wearing a black shirt. So you would count up how many people have on black shirts, and then you would divide that by the total number of people sitting in the classroom. So that's basically what's going on here. So we're basically picking a random stick. If I count them, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 sticks actually, because we have to include that 0. So all of my totals for these are going to be out of 11. Okay, so the first one says, what is the probability you pick a stick that is less than or equal to 9? So we're talking about all of these numbers. So if I count them, there are 10. And when I do 10 out of 11, that gives me 0.91, which as a percentage would be 91%. Number 2, what is the probability that you are greater than or equal to 5? So that is all of these numbers, and there are 6 of them. 6 out of 11, 55%. The next one is the numbers that are greater than 5, but less than or equal to 9. So it's these numbers in the box, which there are 5 of, which gives me 45%. The next one asks for the numbers that are less than or equal to 5 and greater than or equal to 9. So that includes all of these 6 and 2 more, which gives me 8, which is 73%. What is the probability you pick something greater than or equal to 4, which is all of these, which is 7? 64%. What is the probability you pick numbers less than or equal to 7, which is 8, which I know from number 4 is 73%. What is the probability that you are greater than or equal to 4, but less than or equal to 7, which is 4 of them? 36%. And the last one, what is the probability that you are less than or equal to 4 and greater than or equal to 7, which is 9 of them? Do we have one of 9? No, 9 out of 11. 82%. 2 circular flower beds are to be made on a plot of land that is 24 by 12, as shown in the diagram. So if we know that this height here is 12, that tells me that my diameter is 12 and my radius then is 6 for each of these circles. Both circles would have the same thing. So find the area of the rectangle. Well, this goes back to the beginning of this chapter, where for a rectangle, we just do length times width. So I'm going to do 24 times 12, which is 288 feet squared. Find the area of the 2 flower beds. So I have 2 circles. So I'm going to do 2, and my circle formula is pi times radius squared. So pi times 6 squared. 226.2 feet squared. Before the flower beds are planted, a stake is placed at random on the rectangular plot of land. What is the probability that the stake is located inside one of the flower beds? Assume that the area of the stake doesn't matter. So I want, because I'm doing this proportion here, the number I want is inside the flower beds, and here is my flower beds. So 226.2 out of the total, which is 288. Gives me 79%. A skydiver jumps from a plane and lands in a square field that is 1.5 miles on each side. In each corner of the field, there is a large tree. The ropes of the parachute will get tangled in the tree if the skydiver falls within 1.1 miles of the trunk. So here's my tree trunk, so that would be 0.1 mile. So on my circle, the radius is 0.1. The diameter then would be 0.2. What is the probability, so I'm doing the number I want over the total, that the skydiver will land in the field without getting caught in the tree? So first I need to find the area of the field, which is 1.5 times 1.5, which is 2.25 miles squared. Then I need to find the area of the trees. There are 4 of them. So I'm going to do 4 times pi times radius squared, so 0.1 squared. And the area covered by the trees is 0.13. And I do not want him getting caught, so I need to figure out what is the area that there are no trees. So 2.25 minus 0.13 gives me an area with no trees of 212 miles, 2.12 miles squared. So for my probability, I'm going to do the part where there's no trees, which is my 2.12, divided by my total area, which is 2.25. Gives me a 94% chance that he will fall into the field without getting caught in a tree. A dart lands at a random point on the rectangular target shown at the right. What is the probability that the dart lands on the 8-inch square? So if this is an 8-inch square, I do 8 times 8, which is 64. Out of my total, which is 10 times 22. And 64 out of 220 is 29%.